All right, so in this video, we are going to do this. We're going to write balanced chemical equations for each of the following descriptions of chemical reactions. So we don't need to include phases, which would be, remember, solid, liquid, gas, and those would be placed right here. So this is going to be a solid, mercury. This is going to be a gas. Okay, this is going to be a solid. That's how that would look. That's not necessary. Well, that's not a subscript. That is a subscript, but that's not a number subscript. That just represents what each atom is, what phase it's in. Remember, there's solid, liquid, and gas phases. So we don't need to put those in. So we're going to convert the names into correct chemical formulas. We don't need to go back. We got this. So we know right off the bat, let's do this. Aluminum is Al. We know that we have copper. It reacts with copper, right, to produce aluminum, aluminum chloride, and plus copper metal. This is reacting with copper 2 chloride. So we're going to do this. I'm going to show you the balancing of charges again. So basically, when you see this right here, this 2, that's representing the charge. That's for metals only. Metals in the transition area, remember, you don't really know the charges. That's why we skip them. Let me show you. We kind of know the charges here because this is a +1 in group 1. I can't write on my screen. I wish I could. But this, I'll check that. This is a +1 charge. It's group 1. This is obviously a +2, right? +2. And then if you jump these transition metals, because we don't necessarily know unless they tell us the charge, what they are. So it's going to be, this is going to be +3. These are going to be +3. These are going to be 4 minus or 4 plus. These are going to be -3, -2, -3, -3, -3, -3, -3, -2, -2, -2, -1, -1, -1, and then finally 0, because these are inert, noble gases. They don't have a charge. They don't react because they are fully stable with 8 valence electrons. Now let's go back. We'll keep switching back and forth a little bit. So, yeah, she's beautiful, I know. So let's go back. So we have aluminum, and then we have copper 2 chloride. So it's saying that we have 2, the power of 2 plus 2, right? And then chlorine is a -1. So we're going to do our crossover method. Boom, boom. So now our formula is going to read so far, put a dash here, aluminum plus copper chloride, Cl2, is going to yield for us aluminum chloride, and aluminum is a +3. Notice, +3. Aluminum's right here. That's in the +3 column. So therefore, we have a +3 charge. So we're just going to write that down here. That's going to produce for us aluminum +3, -1, crossover 3. That's going to produce for us aluminum Cl3 plus Cu. Okay, so that is our equation. Now, let's balance it, okay? Let's balance it. So in this, we have aluminum, we have copper, we have chlorine, my bad. We have 1, and we have 2 over here. On the left, on the reactant side, we have 1 aluminum. On the product side, we have 3 chlorines, and we have 1 copper. So the one we need to balance right off the bat is the chlorides. Remember, 3 and 2, you could never do that. So we're going to think commonality. So we're going to need a 6. So we're going to put a 3 here. It's going to give us 6 chlorine. That's also going to give us 3 coppers. So now we're out of balance a little bit more. So let's see what we can do. We need 3 coppers. Let's balance it. 3 coppers. So now we got 3 coppers. Now we are going to need 6 chlorine. So we're going to put a 2 here because 2 times 3 equals 6. gives us 6, but now that messed with our aluminum. Luckily, it's by itself. So now we're going to have 2 aluminum on this side. We put a 2 here, and we have a balanced, written out chemical equation with the proper charges. So let me just write that a little clearer. So that's going to be 2 aluminum plus 3 CuCl2 is going to yield for us 2 aluminum chlorides, Cl3, plus 3 coppers. All right, so let's get it done. Hopefully that helps.